All right, guys. So we have section 7.4 today. We're going to do it through a video, obviously. And what you're going to notice is for the theorems, I already have them written out. So if you're following along and you're taking notes, feel free to pause this so that you can write them out. I just didn't want to take the extra time, just sit there and write out all of the theorems. So we're going to start with the triangle proportionality theorem. And it states that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So I'm not going to draw a picture, and I'm just going to come down to example 1. And so we are given that DE is parallel to BC. And all this question is asking, what can we conclude? And it's just a direct representation of this theorem. And so we have the hypothesis that a line is parallel to one side of the triangle, and it's intersecting these sides AB and D and AC. And so if we read the conclusion, it says it divides the sides into segment of proportional lengths. And so we look at the sides of AB and AC, and we see that DE is splitting it. And so what we can conclude is that this side of AD over the second side of DB is going to be equal to the side of AE to EC. And so when you're setting up that proportion, and we can flip-flop those and do the reciprocal property and the interchange means property, but it's just important of how you're matching them up. So I started with one side of that triangle, all right, and I split up coming from A, all right, and then from that other point D. And so on the other side, you also need to make sure that you're setting up coming from A and then from that other segment, EC. So this is important. And so you could flip-flop those if you wanted to. We could use the interchange means. That would say, all right, well, I want to match up AD with AE. And that's perfect because those are both coming from that vertex A. But when you set up your other fraction, you want to stick with the same side. So because I started on top with this segment of AB, you need to make sure that you're matching up DB and then EC. Okay, so that's just the interchange means, but it's also just making sure that you're matching up the same side with the same side. Okay, so if we apply that now, all right, we're given that ST is parallel to RQ, and we're given that PT is 7.5, and TQ is 3. And we're given that SR is 2.5, and PS is what we're trying to find. So this is going to be my X. And in the past, what we had to do in order to do this question is we had to look at the small triangle to the full triangle, right? But what we're going to do now is we're going to set this up using the triangle proportionality theorem, and I'm going to set up PS, which is X, is to 2.5, as that same segment coming from P, but on the other side, which is 7.5, is to 3. Okay? And so we're going to cross multiply. And so we're going to get 3x is equal to, and then we're going to multiply, sorry, I don't have my calculator with me, 7.5 and 2.5. Okay, so 7.5 times 2.5 gives us 18.75. So we have 3x is equal to 18.75. And then you divide out that 3, and we get x is equal to 6.25. And because what we're looking for is PS, and that's what x represents, that's our answer. Okay? Now, our next one is the converse. And so we should be able to already understand what this is going to ask us for, because in the theorem, we were given that it was parallel, and then we concluded that the segments were proportional. In the converse, we're given that the segments are proportional, and what we're trying to prove is that the line is parallel. So in example 3, it says, determine if the lines are parallel if EH is 3 HF is 9, DG is 4, and GF is 12. And so what we're trying to determine is GH parallel to DE. And so to check, we just look at our scale factors. We try to see if they're proportional. So I'm going to match up DG to GF, which would be 4 over 12, which gives me a scale factor of 1/3. And for this line to be parallel, this side of EF has to also be split up into proportional segments that would match that scale factor of 1/3, in which it does. And so 3 over 9 is also equal to 1/3. And so that means that these two sides are split into proportional segments, which means then that GH is parallel to DE. Okay, so I'm going to stop here, all right, and then I'm going to make another video starting with mid-segment.